Another important terminology of the business that we need to be aware of. So it is called detection and attribution. Okay, so I said in a podcast a couple of minutes ago that even though the temperature from year to year is going up and down, the decadal change in temperature has been almost monotonically positive. So you go back to the 1880s and look at each decade. Okay, so we were below the long-term average till about the 1930s. So that's the baseline you can think about as 57 degrees Fahrenheit, 15 degrees centigrade, and 1940s got warmer. We had some ups and downs, but since the 1980s, you can see that each decade is warmer than the previous decade, and we will see later on that record-breaking years are happening more and more now. The warmest years on record are occurring more and more frequently, and the record is being broken also along the way, right? What does this mean? That means we are detecting a change. Okay? When you detect a change that can be verified as a real change over a certain time, and you can call it a trend, a change can be reversed, but here we are saying we are moving in a monotonically moving away from normal. That's a detection. Okay, here is an example of detection of climate anomalies and events in 2019. Okay, there are many, I won't go through all of them. This kind of report gets put together every year by an international team and is published in the Bulletin of American Meteorological Society and so on. Every July it comes out for the previous year. So global average temperature, land and ocean. So Alaska had its warmest year on record. Arctic sea ice during its growth season, it had its 7th smallest ice extent. North America had warmer than average year, ranking 14th warmest record, coming down here into our region. Cyclone Kiar had maximum winds of 240 kilometers per hour, was one of the strongest cyclones on record in the Arabian Sea. You had Typhoon Hagibis, had maximum winds of 260 kilometers per hour, and so on. So pretty much over the ocean, over land, on all continents and in all oceans, pole to pole, you have detectable significant climate anomalies and events now each year. Okay, so these are detected anomalies. Attribution means now you have to go back and take each of these events and show that their occurrence happened because of global warming, or the probability of their occurrence was increased because of global warming. That's called attribution. Models are used, data is used. There are ways to, in a model, we will see what a model is later on. You can remove global warming and produce what is called a counterfactual climate, or a climate that would occur if there was no human activity, only natural variability was happening, considering solar changes, orbital changes, and everything. And then you can add greenhouse gases and land use change, deforestation, etc., agricultural land, irrigation, all sorts of details, and see if the probability was increased for certain harmful events. If a cyclone was made stronger because of global warming, if it intensified much more rapidly because of global warming. These are the attribution exercises. It's not always easy, but they are done. It's not always also clear what can be done with attribution, but it's clear that more and more attributions showing the impact of climate change helps us to realize that we are headed in a wrong direction, and that some regions are becoming more vulnerable to either very heavy rains, very strong cyclones, very long-lasting and harsh droughts, coastal sea level rise, crop losses, etc., etc., etc. Right? So that's what detection and attribution are good for. Very important part of the business, not very easy, but something that is done now by teams of scientists who coordinate across the globe and produce reports every year for every ocean, for every continent, all the events they can. So now observation system is better, recording, monitoring is better, detection is better, attribution is better. Okay, so you have to be aware of this detection and